So next we want to perform a procedure called eliminating the parameter. So what you want to do here is you want to take your equations x of t and y of t, your two parametric equations, and eliminate t. So you get rid of t and just find out what the equation is in x and y. So remember the first example we looked at, we had x is 2t and y is t squared minus 2. So that ended up being a parabola. Let's see why. So if x is equal to 2t and y is equal to t squared minus 2, then we can divide both sides by 2 here, solve for t. So you get t is equal to x over 2, and then plug that in here. So we actually get y equals x over 2 parentheses squared minus 2, which is equal to x squared over 2 squared, which is x squared over 4 minus 2. So this is a parabola here that is multiplied by 1/4. So that's a vertical compression, and then shifted down 2 units. So if you were to sketch this thing, it has a y-intercept at -2. That's when x is equal to 0. And it looks like a parabola opens upwards. So, and that's the graph that we saw before. Now we would have to plot points x of t, y of t to find out which way the arrow goes, but here we at least know what the equation is in x and y coordinates. How about x equals e to the t, y equals e to the negative t, where t can be any real number? So again, we want to solve for t and substitute into the other equation. So let's see here. So if x is equal to e to the t, then take natural log on both sides. So ln of x is going to equal ln of e to the t. And then ln and e cancel, and that's just t. So we're going to put that as an exponent here. So your y is equal to e to the minus t, which is minus ln x. So e to the minus ln x. And remember, this negative is actually a -1 out in front, and that exponent can factor up onto the top, so we can get e to the natural log x to the -1, and now e and ln can cancel, and we get x to the -1, which is 1 over x. So if we graph that, we just get a parabola. I got to be a little bit careful here. X and y are both written in terms of exponentials, which can never be less than 0. So we actually can't have this part of the graph here. Okay, so this guy's gone because our x and y are going to be strictly greater than 0. So, or really, if you just specify your domain, x is greater than 0. So we would say y equals 1 over x, and then x is greater than 0. So now notice up here we didn't have a restriction, because as t varies from -infinity to infinity, so does x. Sometimes you do have restrictions though, so watch out for those. So try WebAssign section 10.1, problem 2, see how that goes.